Welcome to Educator.com. Today's lesson is our first lesson on factoring, and we're going to be starting out by factoring monomials. Beginning with the review of some definitions. Recall that a prime number is a whole number greater than 1 whose only factors are 1 and itself, meaning it is evenly divisible only by 1 and itself. For example, 2, 7, 11, and 17. If I try to break down, say, 7 into a product of two other numbers, the only thing I could come up with is 1 times 7. I cannot break this down any farther, so it is a prime number. A composite number is a whole number greater than 1 that has more than 2 factors, which means all the other numbers, except 1. Notice that 1 is excluded from both of these definitions. 1 is not considered prime, nor is it considered composite. It's actually a special case. So other than 1, the rest of the numbers are either prime or composite. So let's look at a number such as 4, 10, or 20. Taking 20, for example, I can break down 20 into 2 times 10. I can actually further break that down into 2 times 5. So 20 is divisible by 2, 10, and 5, as well as itself and 1. So it is a composite number. We say that a number is in prime factored form if it's written as the product of its prime factors. For example, if I look at a number such as 28, I can factor that out into 7 times 4. However, this is not in prime factored form because I can further break down 7 times 4 into 7 times 2 times 2. This is prime factored form. We say that a monomial is in factored form if it's written as the product of prime numbers and variables with an exponent of 1. So I have two separate entities I have to address. For example, with 27 x cubed y to the 4th, I'm going to need to factor out the 27 and also the variables. So for 27, 9 times 3 is 27, but I need to write it as the product of prime numbers. 9 is not a prime number. I can go a little bit farther with this and express it as 3 times 3 times 3. Now, for the variables, x cubed y to the 4th, I need to express these as variables with an exponent of 1. So instead of x cubed, I'm going to say x times x times x. Instead of y to the 4th, it's y times y times y times y. Okay, when I put these two together, I will get my monomial in factored form. So this monomial, written in factored form, would be expressed as 3 times 3 times 3 times x times x times x times y times y times y times y. Okay, and it meets my definition. I have the product of prime numbers and variables with an exponent of 1. So this is a monomial in factored form. Okay, greatest common factor is a concept that you've probably heard before, and we're going to review it, and we're going to also apply it to monomials and eventually to polynomials. So if I'm talking about the greatest common factor of numbers, that would be the product of their common prime factors. And notice it says common prime factors. Let's look at what that means. If I have 72, I can break that down into 2 times 2 times 2 times 3 times 3. That's in prime factored form. I cannot go any farther with that. Now, if I take 120, that can be factored out into 2 times 2 times 2 times 3 times 5. Now, I'm going to look for the common factors. They each have this 2. They each have a second 2. They each have a third 2. They each have a first 3. Now, there's a 3 up here I'm not going to include. I can't just say, oh, there's a 3 down here, I'll just take all of these 3s. They have to, if there's 3 2s up here and 3 2s down there, those are common. Here, I have 2 3s up here, but I only have 1 down here. So only one of the 3s is common. And there is no 5 as a factor of 72, so I can't include that. So the greatest common factor of 72 and 120 is going to equal the product of their common factors. So 2 times 2 is 4, times 2 is 8, times 3 is 24. So the greatest common factor of 72 and 120 is 24. We can also apply this concept to monomials. The greatest common factor of 2 or more monomials is the product of their common factors when each is written in factored form. So I'm going to approach this similarly. For example, if I have 16 x squared, y to the third, z squared, and 20 x, y squared, z, I can factor these out. And first factoring the numbers. 2 times 2 is 4, times 2 is 8, times 2 is 16. So that is the prime factorization of 16. For the variables, it's going to be x times y times y times y, continuing on down here, times z times z. Okay, for 20 x, y, z, I'm going to get 2 times 2 times 5. That would be the prime factorization of 20, times x times y times y times z. Okay, so I'm looking for common factors. They each have this first 2. They each have a second 2. They each have 1x. This does not have a second x, so I cannot include that. First y, second y, and a z. Therefore, I'm going to look and see what my greatest common factor is. It's going to be the product of these common factors. So 2 times 2 times an x times 2 y's times a z. That's going to give me 4x y squared z. So the greatest common factor of these two monomials is 4x y squared z. We're going to apply these concepts to the following examples. Write in prime factored form the number 360. So what I do is I take 360 and I start out with 36 times 10. You do not have to start with 36 times 10. You can start out with another breakdown. However, this is what I decided to start with. But as long as you keep factoring until you cannot factor anymore, you're going to end up in the same place, no matter what two original factors you started out with. So 36 times 10 can be broken down farther. It can be broken down into 6 times 6 times 2 times 5. And I go on, and that's going to break down to 2 times 3 times 2 times 3 times 2 times 5. And I see that I cannot go any farther. Now, the final thing I'm going to do is to put this in standard form. So standard form would be where I start out with the smallest factors, which are 2, and I cluster those. I put those next to each other. So I had 3 2s, 2 3s, and then a 5. So the prime factored form of 360 is 2 times 2 times 2 times 3 times 3 times 5. I cannot go any farther with that one. Next, I'm going to write 144a squared b cubed c in factored form. Now this time I have a monomial, so I first have to address the numerical portion and then the variables. For the numerical portion, factoring 144, I'm going to start out with 12 times 12 and break that down I can break it down farther. It's 2 times 6 for that, times 2 times 6 for the other 12. I can go even farther. 2 times 2 times 3 times 2 times 2 times 3. Putting that in standard form, 2 times 2 times 2 times 2 times 3 times 3. Okay, now addressing the variables. Those need to be expressed with exponents of 1. Okay, so this can be rewritten as a times b times b times b times c. Putting the numerical and the variable portion together, the factored form of 144 a squared b cubed c is 2 times 2 times 2 times 2 times 3 times 3 times a, b, 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 c. So this is the factored form of this monomial. Okay, example 3 asks to find the greatest common factor of 45, 60, and 150. Remember, to find the greatest common factor, I'm going to first put each of these into prime factored form, and then I'm going to find the product of their common factors. 45 equals 9 times 5, which equals 3 times 3 times 5. 60, I'm going to start out with 20 times 3. That breaks down into 4 times 5 times 3. Still not in prime factored form. 4 can be broken down into 2 times 2 times 5 times 3. Now I'm in prime factored form with that one. For 150, I'm going to start out with 10 times 15. That can be broken down into 2 times 5. The 15 can be broken down into 3 times 5. Now, to make these easier to look at, I'm going to put them in, make sure that they're all in standard form, which they are not, so I can more easily compare and figure out what the common factors are. This first one is 3 times 3 times 5. That's already in standard form. 60, well, I'm going to put my 2's in front, then the 3, and then the 5. Okay, makes it easier to compare. And finally, 150. I have a 2 times 3 times 2 5's. Once it's in this form, I can easily see that the common factor, the greatest common factor, would be, well, there's a 3 in the first one, the second, and the third. This one does not have a 2, so 2 is not a common factor. Each of them also has 1 5. So the common factors are 3 and 5, which is 15. So the greatest common factor equals 15. And I figured that out by putting each of the numbers in prime factored form and then figuring out what my common factors were, and they were 3 and 5, finding the product, and that came out to 15. Finally, I'm going to find the greatest common factor of 3 monomials. Again, the approach is to put these in each in factored form, find the common factors, and then find their product. Okay, so I'm starting out with 24 x squared y cubed z to the 4th. First, working on the 24. That factors out to 6 times 4, but that's not prime factored form. I'm going to go a little farther and take that to 2 times 3 times 2 times 2. And then I'm going to write it in standard form. 2 times 2 times 2 times 3. Okay, so I've got the number. Now I'm going to look at the variables. I need to have variables with exponents of 1. So rewriting x squared as x times x, and y cubed as y times y times y times the z's. Okay, next I have 40 x to the 4th y squared z. 40 factors out to 8 times 5, which can be further factored to 2 times 2 times 2 times 5. And that's already in standard form, least to greatest numbers. Okay, looking at the variables. X times x times x times x, so that's x to the fourth, times y, y squared, times z. Okay, finally, 60 x cubed, y to the sixth, z squared. 60 factors out to 3 times 20, which further factors out to 3 times 4 times 5. Keep going till you get 3 times 2 times 2 times 5. In standard form, 2 times 2 times 5. This is a long one, so I'm going to move this down to here. 2, and 3. 2 times 2 times 3 times 5. This is standard form of prime factorization of 60. Looking at the variables, x times x times x. 6 y's Okay, I've got 6 y's and 2 z's. All right, now I have to figure out what my common factors are. So the greatest common factor is going to be the product of those common factors. So I first look at the top one, and I have 1, 2, 3 2's. I have 3 2's here, but down here I only have 2 2's. So the largest amount of 2's that I have that are in common is 2. I have that here. I have it here, and I also have 2 2's here. Okay, let's go on to look at 3. I have a 3 up here, no 3's here, so that's not a common factor. Okay, looking at variables, I have 2 x's. Okay, I have 2 x's here as well, and I have 2 x's down here. So x, x, those are both common factors. Looking at y, I have 3 y's here, but only 2 here, and I have 6 here. So the greatest number of y's would be 2. That would be the common y's. Z, I have 4 z's, only have 1 z here, and 2 z's there. Okay, so z is also a common factor. Multiplying this out, the greatest common factor equals 4 x squared, y squared, z. On today's lesson, we discussed factoring, reviewed some definitions, and discussed how to factor monomials. And I'll see you again soon on educator.com.